Yeah, so today we'll be solving the lead code question 138, copy the list with random pointer. So basically in this linked list, this is a normal linked list except there's one more parameter that we are storing inside the list, that is the random pointer, which will basically store the value of a node, of a random node. Like let's say here in this case of node P, the random pointer is pointing to node null. In the case of node 7, the random pointer is pointing to node 5. In the case of node 4, it's pointing to node 3 and so on. So basically we have to make a deep copy of the linked list as they have given in the question, right? And that's a pretty straightforward question. It seems very complicated, but it's just we have to create a copy of it, right? Now, let's say if we create a node, we want to do it in just one pass. It's it's kind of difficult because when we are at, let's say, so when we have created a node P, right, a new node P, let's basically copy of it. And if we want to create a next node, we can easily create it for next node, and we can just point the current dot next to that node, right? And let's say we can store the value in previous variable, and we can store the value of this in current variable. So, but let's say the three next the random pointer is pointing to null, or let's say the three random pointer is pointing to node 5. Now, node 5 is not existing right now. It's going to be created in the future, right? So right now we cannot fill the value of node 5, right? So similarly for the next nodes as well, we cannot just put the random values initially. So what we're gonna do is basically we will do it in two passes. The first pass will basically create all the nodes. Okay. So what we have to do is basically we'll create these nodes of a basic copy. Let's say copy of 3. Then we will be creating copy of each node 7, 4, and 5. And then we'll be storing the mapping of this value inside a hash map. Okay, the hash map will be storing all these values of the uh, main list and the copy of it. So we're just gonna traverse to the new created linked list, and we're gonna see if 3's next is 7. What will be 3 random? We will check in the hash map. We'll see 3's random is 5, let's say. So it will point node 5. We'll go to now the next pointer, that is node 7, and so on. So it will just go on traversing and checking in the hash map what's the value of next and the random bit. So that's how we are going to approach it. So let's see while we code the actual value. So let's first create the hash map, right? So hash map, let's say we call it as map. Uh, okay, new. So that's the hash map syntax. Inside the map, let's say we'll be storing two values. First will be for the original node, so it will be node, and second will be the copy of the node. So and it's the similar node, right? So after that, we will traverse through the uh, we'll traverse through the linked list. For the traversing, we'll create a copy of the head node because we don't want to lose the node, right? So we create a current variable and we'll store the value of head inside it. Now we will traverse through the uh, linked list until the current reaches the null of it. Okay, this is simple traversal. And what we're going to do is basically we'll be creating a new node and we'll be storing the value of that new node inside the map. Okay, so for creating a new node, we'll be doing node copy. Okay, let's name it as copy. New node. And for creating the value of it, let's say we'll be taking the value of the current node. So because we have to create the exact copy of it, right? And now what we can do is we can put this copy node inside our map. So map dot put builds the original variable that is current, and the copy of it as copy. And now we'll just move to the next pointer. So current equal to current dot next. Okay, so now what we'll do basically this loop will help us to create a copy of the original variables, right? Copy of this original node. So now we will again initialize a new loop for the second pass. Okay, but the current pointer has reached the null. So again we have to initialize the current with the head value, and now we can just traverse uh, each element of the uh, node one by one. So we'll check the map. Okay, so we'll do map dot get current, right? So this will give us a value of a node that is basically the copy of that node. So node copy, let's load it in node copy. And now we are basically using, so I'll just showcase it. So we have created the copy of this P7, right? And our current is basically pointing here. So now, yeah. So we have created this node, right? And we have extracted the value of that node from our uh, map, hash map. So now we need to see next where it's pointing and also the random where it's pointing. So that values we can get by using the original node. Okay, the original node that is present over here. So this mapping we have already stored inside this hash map, right? So the next value we can also get by using the hash. So what we're gonna do is basically copy dot um next. Okay. Uh, yeah. So copy dot next will be map dot get current dot next, right? So this is the current pointer, right? This is the current pointer, and this is the copy that we have created. So the current dot next that is 7 will be obviously similar to the copy dot next. So a copy pointer is right over here right now, right? So we have already created the copies of it. And also likewise the copy dot random pointer will be map dot get, and this will be similar to the current dot random. Okay, and then we will move current pointer to current dot next to go to the next element. So eventually, so in the first pass we have created these arrays, right? Eventually this will point, make a similar copy. Now this copy, the current will move to another variable, that is this variable 7. Then we will get the value of copy from the map. So this copy will point to now 7. Then copy dot next value will get from current dot next. Copy dot random will get from current random. Then we'll move forth and then so on until we reach the end of the uh, actual linked list. So for returning the value, we can just, so we have to return the value of the, so this variable, right? This variable, the copy of the head. So for that we can do, let's say, so for that we can just do map dot get, and we want the copy of head, right? So you can do uh, right. Let's run for any syntactical error. Let's check if there are any. Okay, it's running properly. Let's submit and check for rest of the test cases. Okay, so it's working properly. Also, there can be an edge case that we are missing here over here, that we will add over here after creating the map. So we also have to put null values inside this, because let's say let's say let's say for any variable. let's say for the fifth variable, the next of it is null, right? Or for any variable, let's say for variable t, instead of this, the link is actually going to the null pointer. Okay, so so here, if you see, when we are using the current.random, the current.random will actually give us the value null. So that value will be stored in copy.random, right? So, but inside the hash map, we don't have a mapping for the null pointer. So that's the reason we have explicitly stored the null pointer over here. But by default, the map get value if we don't get any specific value inside the map, then by default it will give the null output. So that's the reason, even if you don't include this exceptional case, it's fine. The code will work. But I guess it's good to explicitly include it in our code, right? Talking about space and time complexity, obviously the time complexity of n, because we are doing two pass traversal, so it's n and n, so it's like O of 2n, which ultimately boils down to O of n. And also we are storing all those values inside the hash map, all the node values. So there are, let's say, n nodes. So that's the reason we have time space complexity as O of n. So yeah, that's it for the, so thank you.